Hi there, future P's. This is Wasim Asgar. In this video, I'll be answering a question related to power flow that I received from one of my students during P Power live training. The NCS P Power Reference Handbook provides limited details about power flow. Within my P Power program, I go over 6 detailed scenarios to help my students understand how the voltage magnitudes and the difference in phase angles impact the real and reactive power flow. It is an important concept not only in power generation, but also in protection. You'll see me answering this question using first principles, which is very important if you want to have a good handle on the conceptual and theoretical questions on the exam. If you have any questions, comments, or suggestions, please share them in the comments section of this video. So without further ado, let us dive into the content. Power flow. So power flow, remember what I told you guys about the equivalent circuits. The general theme with the equivalent circuits, whether you're dealing with the transmission line, the transformers or motors, right? The generators, are they on three-phase basis or single-phase basis? What do you guys think? Single-phase basis, right? So the student, very good student of mine, she's asking, I have a question regarding power flow, specifically the equation for calculating real power. I see the study guide from the study guide that E1 and E2 are phase voltage values. Why are these phase voltage instead of line voltage? Also, using the square root 3 indicates a Y configuration to me. This is something I'm struggling with in transmission lines. When to use line and when to use phase? Do you have any conceptual advice? And she included this formula. So I think if you are very, very clear about the fact that all the equivalent models are based on single phase system, it is automatically going to take care of pretty much all of these questions. So when you derive these power flow equations on a per phase basis, you're essentially looking at one phase. This is my response, by the way. One phase of the system. So E1, E2 represent phase voltages line to neutral at the sending end, the receiving ends of the transmission lines respectively. Your observation about the square root of 3 being associated with Y or star configuration is correct. In a Y connected system, the line voltage is square root 3 times the phase voltage, but don't let this confuse you in the context of power flows. So she was asking about like how to do with square root 3 and 3. So once I've clarified that these are phase quantities, right? Then what does this 3 make? This 3 basically means that when we are multiplying it by 3, then this is the total 3-phase power, right? For the total 3-phase load. Does it make sense? Is that clear, guys? So a good question, very interesting question, and something that we need to understand for deeper level of, comprehension. Okay. Any follow-ups on this? Yeah, it is also assumed to be balanced. You're right. It is also assumed to be a balanced system. Another student of mine, he works in the MEP environment consulting. Those of you who work in the MEP environment, you know that design reviews are a big part of your day-to-day job. And you send comments to the client, or you send deliverables to the client, and the client sends you comments, right? And then you're reviewing the data from vendors, and you are sending your markups and reviews to comments to the vendor. So in short, this student of mine has excellent PDF editing skills, as you can see. So he sent me a PDF that basically contains, you guys cannot read it, don't worry about it. These are basically questions related to power flow from the quiz in the on-demand. And look at how he is comparing even the problems within the quizzes. And no surprises that he took the exam recently and passed it in the first attempt. Okay, it was a good question, and that's why I'm including this here. Although it was his second attempt, he had used another program previously, but first attempt with me. Anyways, so what he is saying is that, Wasim, let me know if there's an error. For the first 4 questions, you included a 3. But in the remaining 3 questions or 4 questions, 3 is missing. Factor of 3 is missing. So what's wrong here? What is the simplest explanation for this? simplest. I give you equation for real power. One equation contains 3 in it. The other equation does not. Exactly. So are there any surprises that the problem statements for 5, 6, 7, and 8, 9, 7 and 8 were dealing with single phase system? And the problem statements, or I should say are, because these questions are still there, for 1, 2, 3, 4 are dealing with 3-phase systems. Okay. As you can see, like the student is very diligent, is going out of his way in order to understand the concept. But sometimes what happens is that when we get into a tunnel vision, we can actually lose the big picture view of things, right? And then he basically responded back and saying, "Oh, sorry for wasting your time. It was something so silly, something so straightforward. I shouldn't have even asked you." I mean, that's okay. I mean, he spent at least half an hour, I would say, give or take, in terms of creating this PDF for me so that he could make his point, right? Which I respect. He made my life easy because with this, I was able to like, okay, you know what? You are just, yeah. What is it called, Jose? Bluebeam? Is that what this tool is? Is it a PDF editor? Okay, Bluebeam. Interesting. I'll keep in mind. Is it free or does it cost? How expensive is it? Any idea? I'll look it up. I don't want to waste your time, guys. But thanks for bringing that up. Okay. So you guys follow my point over here. What I'm trying to say is that despite being so detail oriented, student missed the plot on this particular question. So guys, every single question can contain some trick. Now, the challenge is to recognize when you are overthinking something and when you are missing the details that are between the lines. What is the meaning of reading between the lines? It's actually not stated explicitly, but it's assumed knowledge. Okay. All right. Anyways, interesting question related to power flow. Again, a very detail oriented student. He had taken his FE electrical and computer exam with me. He had attempted the P power exam, I think, at least 2 times with another program. And this was his 3rd attempt. And he ended up passing not so long ago in the first attempt with me. I included this question over here because it's a high quality question. And the context of the question is that the student has gone through the 6 scenarios that we have discussed in the on-demand course. And he's actually thanking me that you outlined it very well. The power flow section of the reference handbook is very light, right? There are just a couple of equations there in the bus admittance matrix, and that's it. In the on-demand course, we go through 6 scenarios. We deal with the real power and the reactive power equations and try and understand what is going on in the context of the voltage magnitudes and the phase angle differences. So he's like, good job with the 6 case studies, but I was going through some additional reference material, Granger, really nice textbook, along with Glover, Sharma, Chapman, Wilde. These are some of the to-go boxes, to-go books for P power. But those of you who are enrolled in my program, you know that there's so much content available in the program that is curated, especially designed, organized, and delivered for P power exam preparation that you really don't need to look anywhere else. Anyways, so the student was going out of his way and working through some additional practice problems from Granger. And he said he encountered a problem where the magnitudes of the sending and receiving were the same. So he went back to the 6 scenarios we dealt with and is like, is this a 7th scenario? Okay, and how can essentially we deal with it based on what we know? So the key thing I want to highlight over here is that what happens to real power and reactive power, if you want to create a 7 scenario, you can, when the magnitude of the sending and the receiving are the same. What do you guys think? Q doesn't flow. Amazing job, Chris. You're right. Why wouldn't Q flow? And by the way, if I'm not mistaken, the equation for Q is not given in the reference handbook, right? So if I say that Vs magnitude is equal to Vr magnitude, let's just keep it Vs. If I look at this equation, I have a Vs square. Can I write Vs square as Vs times Vs? Minus Vs and Vr are basically the same. So this is Vs times Vs. Regardless of what happens in the denominator and the numerator over here, unless it becomes an indeterminate form, which is 0 by 0, right? That is a mathematical anomaly, and then you'll have to do L'Hopital's rule from FE electrical. We are not going there. And practically speaking, this is not a non-zero value. It is the series inductance or whatever. So the numerator is ending up as a big fat 0, correct? This is non-zero, this is non-zero. What ends up happening, or even if this is 0, doesn't matter. Your Q is going to be 0. So for this 7th so-called scenario, one thing is very obvious, that there won't be any reactive power flow if there's no difference in the magnitude. Does it make sense, guys? How did we answer this question? Using first principles. Did we have to memorize anything? No. We learned what power flow is. We learned the equations, what the real power depends on, what the reactive power depends on. And then from that point onwards, it was just a extrapolation of our understanding. What can we say about the real power using this approach? I can simplify the equation for real power, the sending and the receiving. We've discussed that in detail as well, right? So Vs times Vs. Can we most definitely, in definite terms, say that real power is going to be 0 or non-zero? Again, slam dunk. Chris is saying that we cannot comment on real power without knowing the phase angle, because the real power does not really depend exclusively on the magnitude. Okay, it is dependent on the phase angle difference. So having gone through the 6 case studies, do you guys think that you're equipped with dealing scenario number 7, scenario number 8, scenario number 9, scenario number 10, however many scenarios you want to cook up? Correct? Great. So this is my response to the student. And this is a summary, if you guys remember, that I've included in the course as well. Reactive power flow. And I want to remind you guys that the reference handbook is very silent about reactive power flow. Reactive power flow, Q is non-zero only when there is a difference in potential between the sending and the receiving. Magnitude is the key over here. Okay, magnitude is the key. So increasing the voltage magnitude at the sending end will push the power from sending to receiving. And increasing the magnitude at the receiving end. So where was I? I was here. Yeah, if I increase the magnitude on the receiving end, the power is going to flow from the receiving end to the sending end. Okay. What about real power? Real power is non-zero only when there's a difference in the phase angle. Obviously, you can say that, okay, Wasim, I'm going to make sure that the voltage magnitudes are 0 as well, so your explanation goes out of the window, right? Well, for non-zero magnitudes, real power is dependent primarily on the phase angle. It's a sign of the phase angle, right? So increasing the phase angle at the sending end is going to, so this is my sending end, power is going to flow from here to the receiving end. If I increase the phase angle of the receiving end, power is going to flow from the receiving end to the sending end. And to answer your question, equal magnitudes will result in real power flow if a phase angle difference exists. As far as the reactive is concerned, as we established, reactive is going to be a big fat zero. Okay. So I strongly recommend you guys to go through the on-demand content, go through every lecture. And this student, as I told you, like he had used other programs in the past, and but passed it in the first attempt with my program. And he, for some reason, was not aware of the fact that I had a P power program after he passed FE electrical. Anyways, got it done, and you can see that he was putting in a lot of extra time and effort, right? So make sure you utilize the content efficiently, effectively, and do the practice problems, connect the mathematical equations, think about concepts from different angles, and you should be fine. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE electrical and P power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE electrical and P power exam preparation programs, please visit my website, studyforfe.com.